Hey, your amazing neighborhood Sully here. I am back, and today we're going to be doing topic 2. We skipped lesson 2. Sorry, if you really want to go over that with me, no problem. We're going on to lesson 3. All right, it's going to be talking about these in a second here. You can see this is called a planter's box. All right, it has these things that it contains soil. You know, people want to make these, put them in their gardens, or maybe they don't have a garden, they can put them on a outdoor space they have if they live in a city, things like that. So, but that is what a planter's box is. We're going to talk about it in a little bit. Just want to make sure you saw that picture and knew what it was. All right. This is on page 133. We're going to go right over here to page 134. So, the Plantaseed Planter Company is making planter boxes. To make the boxes, it cuts a square from each corner of a rectangular copper sheet. So, this sheet is made of copper. They're cutting a square out of each side. All right, the sheet's 12 inches wide and 18 inches long. What we're going to do is once we cut that square, we're going to bend this up, and it's going to fold a box that we can put the dirt in. All right, and it's going to be all different kinds of sizes. So we're going to try and see what the best size would be ideally. All right, so let's fill out a table here. All right, let's do if I don't take anything out. So I'm not going to take any part out. My height is this part that I take out because that's what folds up. So I'm going to take 0 away. All right. What is my width? Well, I am not taking anything away, so it's still 12. My length is still 18 because I'm not taking anything away, right? If I want to find volume, I have to do height times width times length, and that would equal 0 because 0 times anything is 0, guys. Sorry about that if you didn't know that. All right. Let's do the next one. So I'm going to cut 1 inch out here, 1 inch out here. So if I'm the width, I'm taking it here and here. I'm taking it actually twice. So if I'm taking 1 inch off, my height is going to be 1. I started with 12 and I took 2 of those sides away, which were 1 each. All right, and that gave me 10. Over here, I started with 18 and I'm taking 2 of those again, here and here, and each time this one, they're 1, that would give me 16. And if I multiply those together, 1 times 10 times 16 is 160 cubic inches. All right? Let's do another one. 2. So this is going to be 12 minus 2 times 2. 2 times 2 is 4. 12 minus 4 is 8. This is going to be 18 minus 2 times 2. 18 minus 4 is 14. So we do 2 times 8 times 14, which gives us 224. Now you can see already the volume of the box is increasing. That's great. So what I want you to do, and I really would like you to write these out, complete this table as much as you can. If you can do the H, that's great. So pause the video and complete the table. If you can't do the H, I understand. We'll do that together. All right, so let's take a look here. Hopefully you can agree with these answers. So you can see as we increase the amount we're taking away, the volume increases, then it kind of comes back down, right? It even goes into a negative. All right, so let's see what we can do and find a formula. So I notice these first 2 columns are the same. So if this is H, then I'm going to put an H here. This width column, I have a constant 12 minus a constant 2 times my height. So that would be my width. My length would be 18. It's always there. Minus 2 is always there. This again changes, and that was my height. So if I wanted to find the volume, I would have the height times the width times the length. Just like that. All right? Let's go to the next page, 135. All right. It says, analyze the relationship between the height, length, and width of the planter box. What are the dimensions of the largest box or largest corner that you could actually take out? So if you look at this list, what's the largest one we could take out and still have a box, right? If I take out a 6 by 6, if I take out a 6, I have 0 volume, right? So it has to be less than that. 5.9 would work, right? So I'm just going to say less than h equals 6. Or we could say h has to be less than 6. That would be our qualifications, because anything greater than 6 is going to be 0 or negative numbers. That's not going to work. Write a function. We already wrote a function to represent the volume. But let's formally write it. The volume equals the height times the width times the length. Very nice. That is a very, very nice function right there. Great job. All right, we're going to use some technology, so you definitely need a calculator. And I know this is going to be your first time for a lot of you. Hang with me. Again, this is a great time to pause. Make sure you're with me. I know I'm going to talk fast, but I talk that you can pause. So we have our calculator, and the first thing it says is we want to just look at this window view. We don't want to see everything. We're just looking at here. And to change our window on our calculator, what you need to do is go to the button that says Window right up here. And you'll notice that it has a lot of different things. First one, it says X min. That's your lowest X value you want. Your X max is your highest value. Your scale doesn't really matter because it's going to graph it the same no matter what. Your minimum, your lowest Y value, your highest Y value, and again, your scale. Don't worry about any of the other things. So our X's are going to go from -10. So remember, the negative button is the down here next to the enter key. So we're going to go -10 to 15. Then make sure you go down to your Y's. Our Y's are going to go from -400 to 400. All right. And we're going to graph it and see what we get. Oh, we didn't do anything yet. We got to actually put the equation in. Let's put the equation in. My fault. All right, so you go to Y equals here. I'm going to put X. I can't put in H, so I put the X, which is right here. And now I remember I'm going to put in parentheses, so 12 minus, it was 2H, so we're going to do 2X. Put it in a parenthesis. Close it. Open another parenthesis. 18 minus 2x, again, because our h is x in this situation, right? Now we can press this graph button up here on the right corner, and you'll see it goes all the way down, comes right back up, and everything really nice and nifty, right? All right. So it says describe the key characteristics. Let's talk about some key characteristics. First of all, it definitely increases to a point, then it decreases to a point, and then it increases again, correct? That's one thing. Interesting things, intercepts. We need our y-intercept. So our y-intercept is when x is 0. Now, there's a lot of different ways to find these things. When I know x is 0, I'm going to go to a table. Now, you can see the table function here is the second value on the graph. It's in blue, so I have to hit the second key, second table. And I'm on the x here, so I'm going to go to 0. So what is my y-intercept? 0, 0. So we can write that down. Our y-intercept is 0, 0. Likewise, that's also one of our x-intercepts because the y value is 0, right? When our y is the intercept, we don't move left or right on our x, so the y changes. All right. Let's see what other intercepts we can find. All right, let's go back to the graph. Well, there's an intercept here. Right there, there's an intercept there. We have two more intercepts we can find, and where you can find them quite easily. Let's find them. So I'm going to calculate. See this blue button again above the trace. Anytime I want to find something on the graph that's numeric, I'm going to calculate. So I have to do second calc. Now, a x-intercept is also called a 0. So we're going to go down to 0. Now, you're going to go over to it. Go to the left, it tells you here, left bound, press enter. Then you have to go to the right of it. So the 0's here, I have to go to the right, press enter a few times, boom. It says to guess, you don't really need to guess, so you press enter, and there you have it, 6, 0. So one of our other answers would be 6, 0. We still have one more intercept we need to find, it's over here. So again, I'm going to do the same thing, I'm going to calculate, so second calc. All right, I'm going to go to 0, number 2. I could go down or just press number 2. It's easy. Go over to the 0, and then just follow the directions. Go to the left of the 0, press enter. Go to the right of the 0, press enter. Do you want to guess? No, I'm just going to press enter. 9, 0. So that would be my third x-intercept. All right, so those are some interesting points we have there. Now it talks about some really interesting stuff. It talks about maxes and, what is the maximum value we can have. If we have a planar box, that really matters, right? The maximum volume, would be here because our volume was a y value. So it's going to have an x value associated with, which is our height, but we can find the volume using our calculator. So we're going to go back here. Now, what did I say? Anytime you're on the graph and you want to calculate something, go to here. So I'm going to say second calc. Go down to the maximum. Press enter. Now, same thing applies. Go to your maximum. Doesn't have to be perfect. Then I'm going to follow the directions. Go to the left of my maximum. Just go enough that you know you're to the left of the maximum. Press enter. Go to the right of the maximum. Again, doesn't matter how many. We're just setting a boundary for them to check between. Press enter. See, you can even see the arrows. I believe on the new fancy calculators, they have lines drawn. It's just, that's where they're checking. Do you want to guess? No. Press enter again. It tells you the value. So I'm going to write 2.4 and 228.2. 2.4, 228 point, I've already forgot, 2. But this is the volume. So our max volume would be 228.2, was it cubic inches or feet? I forget if it was inches or feet. You can go check for me. I'd appreciate it. I think it was feet. All right. So here we go. That is how you find the maximum volume, which is really cool. All right. Let's talk about some other things here. Identify the domain of the function. So there's two things we're going to talk about. This is the function. It goes from here all the way over here and keeps going, right? It doesn't stop right here. It keeps going down, 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 down forever. But it's going two directions. Not just down, it's slightly going to the left forever. So that means domain is all our x values. So it's going to go to the left forever. Does it ever stop going right? No, it doesn't stop going right either. So domain of this would be from negative infinity to positive infinity. Sometimes you could say that when it's every number, we use this fancy R, and that stands for all real numbers. Now, the problem situation, it wants to know what is the actual reality here. All right, let's take a look. Well, reality starts here, right, at 0. Just bigger than 0, I have all this volume. Now, can I ever go to negative volume? No. So as soon as I go to a negative volume, I'm done. Well, we know this value. That value is 6. We found it earlier. So we're going to go from 0 to 6. That is our problem situation. Problem situation. That's the reality of it. As soon as you go above 6, you have negative volume, and you just cannot have that. Let's do the same thing for the range. Well, we already talked about it. The range, it went from negative infinity to positive infinity. All real numbers, right? That's great. But we also know our lowest was 0, and we found our highest. What was our highest? 228.2. That is our problem situation. Reality, mathematical. The function goes on forever, but reality says this is what we're dealing with. What do they represent? Well, I like to do this. The x here is our height. The y is our volume, right? So when our height was 6, our volume was 0, right? So anytime we had a intercept, our volume was 0. So it's really, what does this represent? Volume equaling 0. That is what our problem situation is for the x-intercepts. When we have a height of 6, we have a volume of 0. When we have a height of 0, our volume is 0. When we had a height of 9, our volume was 0. All right? That's what it represents. All right, come with me to page 138. There's a lot of writing on here, 138. First of all, I'm going to talk about this word. It's called a relative maximum. A relative maximum is not the absolute maximum, but is a maximum in a certain area. So this area right here is a maximum, but we know the graph goes on forever. There's never going to be an absolute highest point, right? If we had a quadratic, that would be an absolute maximum. There's no point higher than that. We also have a relative minimum. We can find relative minimums the same way we found relative maximums. On the calculator, remember, I want to calculate, so I'm going to go to the blue menu, second, calculate, and I'm going to find the minimum, number 3. And I'm going to do it the exact same way. I'm going to go to it. I'm going to go to the left of it because it tells me to go to the left. I'm going to press enter. Then I'm going to go to the right of it because that's the directions that they give me on the screen. And then I press enter for the guess. And it tells me right there what the minimum is. But it already has it on here. Okay? All right. Those make sense. Is that the absolute lowest point? Absolutely not. The graph goes down forever. It's not going to be an absolute minimum. It's just relative. In this area, it's the lowest point. All right, look at this. A customer orders a planter box with a volume of exactly 100 cubic. All right, so we know that the volume is 100. Okay, and this is just fancy function notation for y equals 100. We can actually do this. All right, let's do this. So let's go in here. We're going to use our calculator. We're going to go to y equals. We have our initial one, so we're going to go out and create a second one. 100. Press enter. I want you to look at the graph. So if you look at it, how many times does it actually hit? So this is how many places the volume is exactly 100 cubic inches. Now, here's the thing though. How many of these are actually going to be viable solutions? Well, just 2 of them, right? Because once I go to negative, none of this matters. I cannot possibly come back here because I'm going to have 2 negatives making this positive, all right? We can't do that. All right. So let's see. How can we do this? I want to calculate something on a graph. How would I do that? Oh, right. Second, calculate. Don't think too hard, but which of these do you think we're going to use? That's right. Number 5. We're going to use number 5. All right. And here's how you do it. You have to just kind of go over to where your intersection is, be close, and then it looks. First curve. Is that the first one I want? Yep. Is that my second one I want? Yes, it is. Do you want to guess? No. Boom. So my first one is 0.54 and 100. All right. Let's put that on page 139. Page 139. We're going to put 0.54 and 100. That means when the height is 0.54 inches, the volume is 100, right? Now we can find the other 2 really quickly. I'm going to do the exact same thing. I want to calculate, go back to second calc. I want to find where they intersect, number 5. I'm going over towards where they intersect, this time here. Is that my first curve? Yes, it is. Is 100 my second curve? Yes, it is. Guess, boom. So 4.76, 100. Do I need to calculate this third one? No, I don't. It doesn't work. None of these values make any sense because if you go back to the original table, what is going to end up happening is we would have 12 minus 14, and that would give me like a negative 2. And then I would have 18 minus 20 or something like that, and it would give me a negative 2. And I'd have 2 negatives. That's why it's giving me a positive y value. But it doesn't work because I can't have 2 negative lengths. I can't have a width and a... So that third one doesn't work. So how many different can we have? We can only have 2 sizes that are exactly 100 long. All right. So your assignment is going to be on page 145. And it's all at page 145. It's this problem similar to this. And then page 146. So 1 through 6, all right? Numbers 1 through 6 on page 145. That's going to be your assignment. Do well. Good luck. Make sure you're asking for help. We want to help you as much as we possibly can. All right, till next time. Later.